Hi everyone, my name is Nazmo, and today in this stream we're going to be discussing Rust testing, the elusive Rust testing. I have with me on the stream Juan. Hi Juan.
Hey, what's up, Nas?
Uh, Hi Juan. You're new to Rust. You had a bunch of questions around testing, so today we'll talk about unit testing, what that means, and we can use this crate, this repo. Actually, it's not it's a crate. It's not published to crates.io yet, but we have an intention to do that. But we can center our questions around this particular repo. So whatever questions you have, we can kind of get that answered in this session, and then we'll do a separate session on integration testing, and then yet another session on end-to-end tests. So
Uh,
yeah, with that, do you have any sort of high-level questions around testing, what it is, why it matters?
yeah, so I mean, just kind of there was a couple questions that came up. I mean, obviously I send you a message on the chat, but for the most part, just understanding how to configure them, what file structure like to put them in, like are we put them in the same directory as our RS files, like our code we're working with,
Hmm.
and importing that test config file. So just like kind of questions around that.
Okay,
I know
perfect.
that's clear, but yeah.
Yeah. So actually, to get started, let's do this. Oops, where did my browser go? Let's say Rust unit testing. So what's you're familiar with testing in other languages, like right, like JavaScript or TypeScript or those types of environments, or
Yeah, like PyTest, JavaScript testing. I mean, obviously,
yeah,
no developer wants to do the testing. It's
exactly.
probably the boring part, but yeah,
I know everybody says write tests, but it's hard to write tests. It's time consuming. It's actually also mentally like not something that it's a natural thing. Like
yeah,
because testing goes so much deeper than writing the test. Because sometimes in order
sure.
to test a thing, it has
Mhm,
to be built in a way that it's conducive to testing.
mhm.
And so there's this whole thing around, and this is a bit, sort of a bit of a digression, but this is actually, there's something called uh, dependency injection. And where is this dependency? DI, dependency injection? Where is this injection? Oh, I am, this is weird. I know that I have dependency injection. What the, what? Dependency Dependency injection. No? What? Let me do a search real quick.
So maybe while you search that, you can probably just what is that you're looking for the injection? Is it
Yeah,
like a
so
module?
no, so like just the concept of dependency injection. Oh, I even have a See, this is what I'm talking about. How did this not show up? There's a
Yeah,
whole
maybe like a little.
category. Huh, right there. Oh, this is Firefox. That's why. Sorry, I'm for the purposes of the stream, I'm using Firefox, but in reality, I use Chrome. So that's
Okay.
why I am a little bit out of sorts with this. Okay, here we go. So dependency injection is a really cool pattern that we can touch upon where it's called inversion of control, where it's the opposite of sort of inheritance. It's a really like some there's this thing where you're supposed to favor composition over inheritance because inheritance leads to all kinds of overhead mentally and even like maintaining code that's really old. Like you end up like inheriting methods and properties or fields that you might not know what they do, and it's a very heavy way of doing things, and there's a lot of assumptions baked in.
Gotcha.
Specifically for Rust, it is not even an object-oriented language. So the only way to do polymorphism in Rust, which is polymorphism is like what is the definition of polymorphism? Let's see. Polymorphism. Like I know how to use it, but I haven't had to define it. Okay,
Yeah.
polymorphism. I see. So it's like oh, I see. It's like an animal. So like in the classic object-oriented, make me an animal, make me a cat and a dog, and they both have a name. So you take the name uh,
Hmm.
method or property, and then you put it in a superclass called animal. So
Okay.
anything that inherits from animal has a name. So you can have a get name or a set name. something along those lines. And so in Rust, polymorphism does not happen through inheritance. It happens through the trait system, because Rust is not an object-oriented language, which so the interesting thing with Rust is that the mental model is it's functional, and so and it's actually data oriented. Like it's almost data oriented, where you really have to think about like, okay, this is my main function. I
Hmm.
allocate some memory, which will be dropped when my main function exits for the most part. And that memory, I have to carve it up into some sections or chunks, structs, and
Okay.
then I have to be very clear about which of these are will be passed to who has
Hmm.
access to these various parts of memory for how long. And so it's kind of like you almost start with the data first. I almost think of it as like data-oriented programming, where you really think about the data, where it lives, how long it lives, who has access to it, what type of access do these other actors have? Is it read-only access? Is it mutable access? Do they have concurrent mutable access? Or is it single-threaded, immutable access? So it's kind of like you really have to think about those questions up front, and then it really makes you like exercise your this is what the shape of my data is, these are the data structures I'll use to represent whatever it is that I need. And you kind of start from there, and then the functions come along, and then you can, for things where you're like doing similar things over and over and over again across multiple structs, then this
Okay.
notion of trait can be introduced, where it's like, oh, trait encapsulates some behavior,
Hmm.
and that behavior, if my struct implements a trait, then it guarantees to exhibit that behavior. So if I
Okay.
want two different structs
Hmm.
to exhibit the same behavior, then I make both of them implement the same trait. So
Okay.
so that's kind of like how you think about it. So and the trait just has functions, and these functions like don't necessarily have an implementation. They're like headers, and then you can implement those functions for specific traits. Sorry, for specific structs. So
Gotcha. So a struct is like a way of defining like a kind of like a type. It has a key and a value, or is
yeah, so a struct is in Rust is essentially a thing that describes the shape of data, and yes, it is a type. So every struct is a type. Rust uses something called the algebraic type system, which
okay.
is really cool. I think TypeScript also has a sort of implementation of that. But the nice thing with that is you can have match statements. So you say something like, so a struct or an enum, they are
Hmm.
both types.
Okay.
And in enum, they're very closely related. A struct has fields, like you pointed out.
Okay.
An enum could just have like constants. Like, for example,
Mm.
you could have an enum that's called enum color,
Okay.
and then that enum could have like red, green, blue. So actually,
Hmm.
while we're here, why don't we just live code some of this up? So you were asking
So
earlier, like, where to put tests, right?
yeah.
So one difference I think between Rust and a whole lot of other languages is that, like in JavaScript or TypeScript, you're supposed like if you use Jest or something, uh, you're supposed to have a tests folder or an underscore underscore tests underscore underscore folder, and you're supposed to put the tests in there. In
Hmm.
Rust, unit tests are inline with the source code. So for example, if I have a main RS, so let's say
Okay.
that we this is I'm just gonna this is just Scratch. So let's say I made a Scratch. This is just for the purposes of our little session. I'm gonna delete this later. So let's say I made a Scratch
Hmm.
Rust file. So here I would say something like so let's say I make an enum, and I say my enum is color and it has red, green, and blue, right? So
Gotcha. Okay.
now I can make a main function. So let's say main, and I can say something like da, 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 something like that. And Actually, this one. So the main function can't be in a file called Scratch. It has to be in a file called main. So,
Oh,
and this was not by accident. I wanted to use this as an opportunity to introduce tests.
nice. Okay.
So this is my test one because I have no imagination with regards to naming this test. So we're just going to take whatever's in here. And look at that. I can run the test.
Nice.
So one thing you notice is that color, whatever this enum color is, it got, I didn't have to import it because this test has, even though it's not pub,
Yeah.
this test implicitly has access to every single thing in the source file. So that's one of the niceties with tests is that internal details are available to unit tests because they're in that file. So you don't have to
Gotcha.
do
So you
any.
didn't have to do any additional configurations. It
No,
just out of the box. Nice. Okay.
exactly. So let's say I had another. Oops, sorry. What is this? What happened? Sorry. Let me just collapse this. So let's say I have another. So let's say I have another struct. I say struct. Yeah, point. Sure. So with with the enum or the struct, if I have pub and then I write a, let's say test, let's call this test color, and then here I can say fn. By the way, if you're wondering what this fn test is, it's called Rust Flash Snippets, and it is this thing. So if you
Okay.
look at this one,
Oh, gotcha. Okay.
it's this extension. It's quite handy. I have Rust Analyzer, crates.io, LLDB for the debugger, and then I have, I think, Toml for, yeah, better Tom, even
Yes.
better Toml. So, but
Yeah.
yeah, so this one, that extension is REST Flash snippets. They're really handy because you can just do like, you can say fn and then control space to trigger autocomplete, and you can say fn
Nice.
test, and then it'll just
Okay.
make that for you. So if I say, for example, test point, right, and I'm gonna take this out, and I can say something like let point is this, and I can say, assert whatever like that, and then whatever. So this one, it doesn't matter if it's pub or not.
Okay.
This code, because it's a test,
Okay.
it will have access to these fields because it's in the same file. So that's one of the benefits. If I later on we'll in another session we'll do something called integration tests. So
Hmm.
in Rust, you can have at the top level source folder. This is where all your source code goes, all the RS files go, and inside of those RS files, you have a bunch of tests, right? In line with the
Okay.
code. So you write a function, test the function, write a function, test the function, whatever. Write a struct, test the struct. Write an enum, test the enum. And if you didn't want to do that, you could do something called integration testing. See that?
Okay. Yeah.
And integration testing is, you can think of it this way. The idea with integration testing, by the way, integration tests go in a separate top level folder. So see this, there's source.
Yeah.
So integration tests would go in a tests folder at this top level and right there. And then here we would make like integration test, whatever, 1.rs or something like that.
Okay.
So essentially, like, this is where integration tests would go, and we won't cover integration tests today, but I just want to give a sense of that. And the difference between
Nice.
integration tests, yeah, and unit tests is that integration tests, you have to have, it's as if this is code that's in a different crate. Someone else is, it has no knowledge of your code at all. So here you have to use the correct imports. You have to say use the module and so on, and you will not have access to the private things. So if you say, like for example, what do we going to call it? Point. So let's say we make the struct pub, and let's say we make this one pub as well, so other things can access it. I have already exported it because of this thing, pub use scratch star. So here we should be able to say something like fn test, and we can say integration test for point. And here we can say something like, oops, let point equals all of this. And so now we have to do that. Let's say, bring that in. Okay. Let's see. Is this?
And that's just bringing in your file, right? So the use TC API server scratch, that's just importing that file into this uh, specific file to be able to test it, right?
Exactly, exactly.
Okay.
So here we can just say point, and why is this not working? Oh, is it? Oh, sorry, TCP API server. Okay, sorry about that. So essentially, what it was saying is that I can't use crate because this is a separate module than that module. So
Okay.
in here, I can say crate. So I can say use crate and then like let's say client message, whatever. That came from somewhere, and this works because we are still inside the same crate. From Rust modules perspective, everything in the source folder is in the same crate. So crate just means self, the crate that is me, and that is
Hmm.
the one, this crate, the one in the cargo tunnel.
Gotcha. Okay.
And so, but for integration tests, this doesn't work because it's saying I don't know who the self crate is because I am an integration test. Who are you talking about? Be explicit about what crate you're bringing this point in from. So here
Hmm.
we have to use the full name of the crate, which is this thing.
Okay, that makes
So
sense.
yeah, here we have to say rebel r. Oh nope, sorry. It's called TCP. Yeah. So now we can get to it, right?
Hmm.
Notice that's red and that's red because these are private. So if you look at point, notice that these are private. So in Rust, if you make a struct and then you make fields and then in those fields you don't have a visibility specifier,
Hmm.
they are considered private. So in the
So they're
integration test,
private by default.
they're private by default, exactly.
Hmm.
So notice that I cannot access X.
Yeah.
Field is private. So notice that I didn't have the problem here. I could easily access X and Y because the unit test gets to access private fields for whatever things are in its module. Pretty sweet, right?
It like bypasses it.
Yeah. It's a compiler
Okay.
makes an exception for it because like, oh, you're a unit test. I get it.
Yeah.
So you have access to because you want a unit you want to test the things inside the thing. So it gives you access. But for integration tests, it's like, oh, okay, okay. Integration test means like your assumption is that you're not part of this crate. You're a separate crate.
Yeah.
You have your own situation, your own context, your own memory, your own setup, your own environment. When you pull in the code, we're making like no assumptions about what you have access to or what you don't have access to. You're basically using this test as far as it's concerned, even though it's in this repo or in this crate. It's as if it's in a separate crate, and
Yeah.
that is what integration testing is. Is that it's to remove a lot of assumptions that exist when you do unit testing, such as I know what that point has an x and a y, but the integration test has no idea. It's like I don't know. I know that you have point because you've exported it, but I don't know what's inside of point. Does that make any sense?
Yeah. Yeah. So essentially, would it be kind of like a way of cleaning up your testing too, like your main file that way it doesn't get congested with all these unit tests? Or does integration tests have additional functions also that you can do that you
It,
don't have in the unit testing?
exactly. It's the latter. The intention behind integration testing is quite different than unit testing. Unit testing is like you're looking inside of your code that you're writing. It's called the code
Yeah.
under test.
Hmm.
You're like the code under test. I am going to take a magnifying glass and I'm going to examine the internals of it. I am
Okay.
making zero assumptions about what's outside of it.
Okay.
In
It's starting
integration
to make
tests,
sense.
Yeah, it's the
Okay.
opposite. In integration tests, you're like, I have no idea what's going on inside of this code under test. I have zero clue. I am an outsider looking at point. I do not know how point is constructed,
Hmm.
but I want to exercise the public API for point. So for example, in this case, if we were to make this real, we would need to make, so in Rust, you can have implementation blocks for structs.
Okay.
And so you can make a constructor, which is pub, and you can say, if I give you an x and a y, you give me back a point. So now I can go to the integration test and I can say point new 1020. And that's okay because this is public. This is, I want to test new. I don't know how new is I don't know how new is implemented, but I'm the consumer of this crate, and this crate provides a struct called point, and I, the external consumer, wants to use point using its public API, but I don't know anything about how it's put together inside. And that's a distinction between integration testing and unit testing. Unit testing is from the perspective, the code under test, you're inside of it.
Hmm.
In integration testing, the code under test is a black box. And you just
Okay.
want to poke a bunch of buttons on the black box to see if it does what you think it should. So in this case, since we cannot access X or Y, what we would need to do is we can give a something like, we can say get X maybe. We can say get Y. And then in the integration test, what we could do is instead of saying point.x, we can say get X. And we can say get Y. And that'll work.
Okay.
Because this is public, that's public, that's public as well. But the properties or the fields of point are private. So
So even if the function itself is public, that public visibility doesn't pass down to variables. You have to be explicit inside the function with the variables that you're indicating that visibility.
exactly. So the fields that make up the struct, yeah, you have to be explicit about their visibility. Like you can say pub here, you can say pub crate. Pub crate is interesting. It means that it should be visible to all the other code inside of the source directory, but not outside. So
Okay.
this would still not have access to it. So we still won't be able to say point.x.
Okay. And are those the only two options that you have in Rust for visibility? Like I know in Simplicity you have four. You have like the view, pure. What are the other two? External, and then the other one's public.
Yeah. So there's a whole bunch of them. So there's pub crate, there's pub like self. Self is even tighter. It's like if this is in a particular module, then it'll be available to all the other code in this module. This module is this file. So
Okay.
now the X and Y are available to all the code in this file, but not outside of this file. This
Okay.
means, oops, sorry. Where did it go? This means that make this X and Y visible to all the code in this crate. By the way, you can do the same here. So yeah, this means that take the symbol point and make it available to all other code in the crate. This
Okay.
means make it available to all other code in the crate and even to other crates. So
Nice.
so here that's kind of like that's what that demonstrates. I still can't get access to point.x because it's private.
Okay.
Because the
Yeah.
integration test is in a different it's considered a separate crate. It's not considered the same crate. I'm not inside of this crate. Hence, it is not a unit test, it is an integration test, meaning that I'm going to take my code, treat it as a black box, and connect it or
Hmm.
integrate it with other code. And I have
Okay.
no prior knowledge of anything. So that's why it's very interesting. Like I don't know that point has an x and a y. All I know is a point has a get x and a get y, and that those are
Yeah.
functions. So this is basically here we can say yeah, this is uh, the x is private. X and oh yeah, actually the comment was correct.
Yeah. There it is.
That's exactly right. So there we go. And so that's actually a pretty cool demo of unit test and integration test. So you might be thinking, what is an end-to-end test? So that's cool. So end-to-end testing is where you take the code that you have and you run it from like a like how a person would a user would run the program. So
Okay.
it's not even that you're running the test, which is an integration test or a unit test. You're literally running the program. And then when you run the program, you give it certain inputs and you expect certain outputs, and that's what end-to-end testing is. So basically, you're like, I don't even know what the functions are that make up this program. I just know that this program does stuff. So for example, if you look at this TCP API server, that's the project that we're in right now, TCP
Okay.
API server. And if you run, actually, one second. If you, sorry, if you run the, let me just clean the terminal. So so basically when you build a Rust program, it dumps the binary of it like in the debug folder,
Okay.
and it's right there. And it's the name of the cargo toml. So if in your cargo toml, I think we had oops, what is going on here? Sorry, we had TCP API server. So you will see in actually let's do target debug. You will see TCP API server, and that's a binary and it's marked executable. Pretty sweet. So if you do
Nice.
cargo build dash dash release, then it will make, so that was a debug binary which gets generated when you run cargo build. So
Okay.
that binary that we just built is
Hmm.
the artifact that would be the artifact under test when we are using end-to-end testing. So
Okay.
end-to-end testing would test that binary. So let's see. If we pull up Ranger again, you'll see that now we have target, and see we have release, and we have
Yeah.
TCP API server. We also have debug, and we have TCP API server. So we have both. And the difference in Rust, the difference between the debug binary and the release binary is that the debug binary has a lot of symbols in it for debugging purposes. So if you're going to be
Okay.
debugging it, you want to debug that binary. If you want to push it into production so other people can install it on their computers, you can generate the release. The release is way faster because they strip out everything that is unnecessary and they optimize it quite extensively. So the debug is typically what we use when we say cargo build. That's we're not usually doing the release because the release to make the release binary takes more time. And Rust, it's pretty slow anyway. The compiler is actually really slow. So uh, so 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 now with target, so let's say we run this thing. What it does is that it goes, when you run it, it gives some help information. This is called CLAP, C-L-A-P.
Okay.
This is also a very good thing to know, Rust CLAP. It's a way to do command line argument parsing in Rust. So basically, oh, that just takes you to docs where we were in the first place. Oops. Okay, never mind. So that was a bit of a circular journey. So here, uh, what you can do with clap is that cargo itself uses it. Um, it's a way to, so when I say like target and I run that binary, right? Clap generated this help. I didn't have to write that by hand,
Oh, okay. I see. Okay.
which is a lie. I did have to write parts of it by hand, but we'll get into that later because this is very advanced clap because it's
Yeah.
colorized. So if you want
Okay.
to do super colorful output like this, then you have to do parts of it by hand. But if you just want just black and white output, then yeah, you can all this can be generated for you automatically. You don't have to write any code at all to get this output. So
With the cloud.
with clap, yeah, exactly. So you
Yeah.
basically,
Nice.
and we can get in clap later, but I just wanted to just kind of give it a shout out to just so you're like, what is this? So
Nice.
here you can do stuff like for the purposes of end-to-end testing, you would do something like, okay, I'm going to start the server on port 5000, right?
Okay.
On address, whatever, localhost, something like that. And
Hmm.
then you would run, you would tell bats to run this, and then you would check to see if the server is up and running on port 5000. That
Okay.
would be an example of an end-to-end test. That means you're like, hey, I told you to start up on localhost 5000. Are you really up on localhost 5000? But you have no idea how it does that. You don't know how it's built. You don't know there's a point in it. Remember, there
Hmm.
was a point struct that we made and
Yeah.
a color enum. You have no idea because you're just like so far removed from the implementation details. You're just like, this is the binary artifact, the runtime executable, the program that you run it,
Hmm.
give it these inputs, see if it produces those outputs. And if it doesn't produce those outputs, then the test has failed. So
Okay.
yeah, so for example, I can run this server on port 5000. Then I can check to see that it's up and running. Then I can try to run it again. And in the bats test, I can check to see that it fails because it's already running. And if 5000 already is attached to a process, then I can't bind to it again. So
Okay.
those are the kinds of things you think about when you're making like a bats test. So it's kind of like you start from inside of the kernel of corn,
Yeah.
then you like zoom out, like there's other corn kernels and seeds and
Yeah.
whatnot. Zoom out even more, and there's like a bag, and then you try to open the bag or whatever, or you put the bag in a microwave. I have no idea. Whatever the analogy is, and so it's kind of like that, where you're like, what level of detail, what what is my scope right now? Where am I?
Yeah.
Am I all the way in the source code where
Hmm.
I am creating, let's say, point, right? Am I here? Then yes, this is unit test because everything in here uh, is visible from the perspective of a unit test. So we're good. Am I outside somewhere in integration as an integration test? Then I can see that there is a point because point was exported, right?
Hmm.
Right there and right there. These export points so they can be used outside of this crate because it says pub here and not pub crate or pub self. So that's cool. So integration test can get to it. That's wonderful. However, integration test has no idea how point is put together. So anything that's private or public in self or in that crate is not visible to me because I am in a different crate.
Yeah.
But then now we zoom out even more and you're like, you know what? I don't know about the crates or whatever. You might have 100 crates that you're pulling in for that
Hmm.
binary that we built. You want to test the binary to see if the final artifact functions as you expect. Then that's the um, end-to-end testing. So I hope that makes sense. It's kind of like, it's almost like super deep, kind of like a little bit farther out and all the way out.
Yeah. No, no, it makes sense. So yeah, just the way that you put it together. So the unit testing is more specific to just that individual file when you're trying to do tests on, let's just say that one, Scratch RS, right? You're
Exactly.
trying to test a function. You probably do unit testing there for that
Exactly.
function.
Yep.
When you want to go outside of that scope and you want to do testing without having that inside knowledge of that main file that you're looking at,
Exactly.
then you do like an integration test and then pretty much the end to end is like the broadest of the scopes, right? So after you
Exactly.
compile all the code, it's testing to see how all that's working.
You got it. That's exactly right. And and so that's in a sort of like a in a nutshell, that's the overview of it. And now
Hmm.
diving more deeply into unit testing is remember I had mentioned something called dependency injection.
Yeah.
That's where it kind of becomes more relevant. So dependency injection is a pattern. It's a way to create software where the dependencies of the function that you're calling
Hmm.
have to be passed into that function as arguments. So,
Okay.
so essentially, you have a function, which is kind of strange. Like normally, you're like, wait, what? So I'll give you an example.
Okay.
So let's say that you wanted to. Oh, okay, so let's say you have point, and you have point that has a function, and it's called pub fn print to standard out, right?
Okay.
So if I run this function, let's run it. We say, right, print to standard out. What do you think is going to happen?
I mean, I can't see. So, okay, so you're saying if you run which function?
So let's say that we have a function called print to standard out,
Okay.
and is the code too small? Should I make it bigger?
No, no, you're good.
Okay,
So it should return pretty much. It's going to print out X, and then it's going to pass in the variables that we put for the function above it.
exactly. So it's just
Correct.
gonna exactly. So like whatever values we set to for point, it's just gonna dump it to standard out. So
Yeah.
we run it, and look, there it is.
Gotcha.
Exactly as you had predicted. So that's great. Um, can I? How do I test that it worked?
How do you test that it worked? So you want to fail the test, right?
Yeah, or
That's how
like,
you.
so let's say that so let's say that point x equals 10 and y equals 20, right?
Mhm.
We know visually from running the test that that's what gets dumped to the screen.
Yeah.
But how do I test that? How do I make an assertion? How do I test this? So let's.
Yeah, I think so yeah, so what I understood from the assert EQ, it's I think it's to check if the variable is equal to what we're testing for, right? So in
Exactly.
this case, it's 10 and 20. So we're saying, hey, is 10 actually, is X actually 10 and is Y actually 20?
Exactly.
And if it's not, it'll fail it.
Exactly. That's exactly right. So if we do 11 here, it'll fail. That's exactly right. And
Okay.
so which tests that tests x and that tests y, right?
Hmm.
But how do we test print to standard out? What does print to standard out even do? It does two things. So let's break it down, right? So let's say that output message. So actually what it does is, oops, oh, sorry, no, okay, format. So we could do, why is this not working? Oh, sorry about this. 1 second.
You're good.
This is just made up nonsense. So let's say that we we have a string that we made
Okay.
called output message, and then we print that output message to standard out. So println is basically a macro which actually ends up calling the print function on standard out. So there's a whole lot of dependencies that are baked into, or assumptions that are baked into this macro, where we don't know how it's put together. I mean, I just showed you how it's put together, but we don't really know how it's put together.
Okay.
So how do we test? So given that we call a function which
Hmm.
dumps this to standard out, and we can see it with our eyes,
Yeah.
how does the test see it? Currently,
Okay.
it can't, because
Mhm.
I mean, what we could do is that we could test this message, right? We could do something like this. This is get display message. We could do
Okay.
something like this, and we can say get display message,
Hmm.
and then we could do, oh sorry, we could do self dot get display message. We could do something like that, and then if I run it, it'll still produce x is 10, y is 20. But now I can have a test, right? I can say something like assert. I can do that because I have access to what's coming out of this function. Whereas this print line thing is a black box. Once you run print line macro, I don't know what came out the other end because it doesn't return anything.
Okay.
So this makes it very difficult to test because you're like, okay, so I can test that. That worked, by the way. But I still can't test that the print function worked. Now, here's the question. Do you care to test that the print function worked?
Uh,
I don't think
well, I
so.
mean, yeah. So in terms of like memory, when the function runs, is the memory gone because it's locally scoped? So
Um,
is that what you're saying? Why we wouldn't want to test for it?
oh, no,
Or
actually, because we trust the print function. Because the
oh,
print
gotcha.
function,
Okay.
yeah, exactly. This is
Because
the,
you know it's a black box, it's gonna return whatever's in that box.
exactly. So this is
Okay.
one of the biggest things about testing is what are you testing?
Yeah.
What is relevant for you to test? Are you testing
Hmm.
your code or are you testing the code that came out of the standard library? You have no
Yeah.
business testing the code that came out of the standard library
Yeah.
because we assume that it's tested and it works. More
Hmm.
importantly, this is a unit test. The scope of a unit test, as the name implies, is the unit inside of which it is contained, which is this file. So
So
for
if we were to remove that exclamation mark and remove that macro, then it becomes something that we do want a unit test, right? Because that print line function, the exclamation mark after it makes it a macro, right? So essentially, it's saying, hey, we're importing a package and we're inheriting that functionality or whatever it has.
so
So if we were to remove it, it becomes something we'll unit test for, or no?
no, actually. So if we do something like standard, let's see, what is it called? Where do you get standard IO? Give me one. If we do like this,
Okay.
dang it, sorry. Import it, please. Okay, 1 second. This is, let's
No,
use,
honestly, I always go to documentation. I feel like a billion times, like looking up commands that I've probably run a ton of times, but
I know, right? Let's see.
hard to memorize them all.
Exactly. So it's just std colon colon IO. So it's like that. So we do std colon colon IO. So we
Mhm.
can just do let std IO
Okay.
equals standard out, and then we can do standard out, uh, right, this is, why is this,
Kind of find value
oh,
and
sorry,
scope.
I'm sorry, it's because I wrote something, so why is this not working, standard out dot right, oh, and then go ahead, why is this not working? Oh, okay.
Mismatch.
Let's see. Let's do this. Let bytes equals. We can do format. Actually, there's no need to do that. It's just get display message. Sorry about this. This is
No,
cell
you're good.
dot get display message as bytes. So that gives us the bytes, and then we should just be able to say output bytes. What's the problem? What's the issue? Oh,
Can you use can you import a module inside a function? Maybe that might be it, or
I think. Oh, sorry about this. I am doing a bunch of weird stuff. Let's say output mess or let display message. So I did something wrong. It wasn't that. It was just me. I there we go. I wasn't using the standard out correctly. There you go. Nope. You're supposed to use right all. Sorry about this. There we go. Ta-da. Okay, and then it's still complaining. Oh, right, right. So we can do whatever. By the way, that's what the print line macro did. All that
okay.
was to show you what the print line macro is doing. So basically, so for example, actually, let me show you a little trick real quick. So we can do, there's this thing called cargo expand,
Okay.
and you can do cargo expand scratch. Oh, it's just integration test. Okay, so, okay, let me show you what this does. So let's say that we put a print line here, right? and we say print line. You're like, what exactly does a macro do? So a macro is essentially, there's two kinds of macros. There's something called the declarative macro, and there's a procedural macro. So, and you can learn a lot about all about it on Developer Life. So you can go to macro, and there it is. There's
Nice.
procedural macros and declarative macros. There's a handbook on it. Check it out when you get the chance if you want to learn more about macros. But a macro is just a way to have the compiler use your plugin to generate source code.
Okay.
There's reasons to use it. For the most part, you should probably avoid writing your own macros at the start when you're learning Rust.
Hmm.
You can use macros, but later on, when you become more familiar with Rust and you have an actual use case where you need to use a declarative macro, then it makes sense to use. If there's a use case to use a procedural macro, then you can use it. But for the most part, it just basically allows this code to be expanded into a whole host of other code by the compiler. And you're like, what code is that? So there's this really cool tool called it's called Cargo Watch. Sorry, Cargo Expand, and you can install it by saying Cargo install Cargo Expand.
Okay.
It's a say Cargo Expand. This thing is awesome. David Tolnay is amazing. He does all kinds of super cool stuff. So
Mm.
Cargo Expand. So what you do is that with Cargo Expand, I can say Cargo Expand, and I could say, hey, take this code that's in here and expand it, expand the macros, unwind it all, and show me the actual source code that the compiler is going to compile. So
Okay.
that's one way to
Nice.
do it. Another way to do it is you could right click on it and actually or you can just say like expand macro. And sometimes that doesn't work. Sometimes it works, but this always works. So
Okay.
I will show you where the print line went, right there.
Yeah.
So the print line just goes standard IO. It calls the underscore print macro
Hmm.
with format args, and it passes this thing. So then we have
Gotcha.
to go look up what the underscore print macro does in the standard library, which we can because we have the source code for it. So we could just follow this, and we see that the underscore print.
Yeah.
So we have to go in the source code for the standard library. So we can say Rust standard library print function, or is it macro? So then we can go in here and so it's in here somewhere, and then we could look at the source code and actually figure out. I'll save you the suspense. It calls right.
Yeah.
I know
Yes,
the
that's
answer.
pretty
I
badass.
was. Mhm.
That's pretty badass how this expand actually shows you the actual code, what you're bringing in.
Exactly, exactly.
Yeah.
So it ends up calling right, and then so basically, when we look at our example, where did we go? Oops, where was it? Uh, too many files open. Which file were we in?
Uh,
Dang it. I
We're
think it was
looking for
point.
the integration test. Yeah, the
Yeah,
one you
this one.
made.
There we go.
That's one.
So this one. Sorry about this. So remember we were originally trying to test print line, and we had
Yeah.
made this thing like we got the standard out and we used the write.
Hmm.
So print is a wrapper on top of write. It basically takes this expression. It's called format args. It turns it in, it evaluate. This is a macro by itself, by the way.
Yeah. Okay.
It unwinds, and there's a reason for doing this. It's to basically get around some typing restrictions in Rust. There's some situations where you don't want to know the types ahead of time, such as here.
Okay.
And I'm saying that with a very soft voice because that is you have to be very careful with stuff like that when you're there's use cases for it, but they're few and far between. Okay,
Yeah.
so with that disclaimer out of the way, so this is a macro which takes this expression and these expressions and generates a string out of it. So what you get, this evaluates into a string. This is, by the way, you can go look inside of format and see what it does. It
Okay.
calls a format function. You can go look at the format function. and you can see what it does. So
All the code seems.
yeah, so basically this thing turns this expression, this expression, that expression, that expression. By the way, in Rust, everything is an expression, not a statement, because it can return a value. There's an if. It's not an if statement. It's an if expression. So you can say
Okay.
let a equals and then say if else. So it's different than JavaScript or TypeScript or other languages where not everything is a is an expression. Sometimes in JavaScript or TypeScript, a lot of things are statements. That means you cannot put
Okay.
let something equals and then put a statement on the right hand side. You can only say let a equals and then you can put a expression on the right hand side. So in Rust, pretty much anything can go on the right hand side. Which
Nice.
when you're not used to it, it looks weird the first time you see stuff like this. Because what this is doing is that I don't know if you noticed, there's no return.
Yeah, you don't have to specify.
No, because this is an expression and it just by default in Rust, when it encounters an expression, which is the last line of that code block, it just returns it implicitly.
Yeah. Okay, that
So
I do remember. Like if you don't put a semicolon at the end of that block,
yeah,
that's your return value.
exactly. So check this out. This is essentially what I was saying is that you can say let it equals format and return it. But
Yeah.
then this you say, well, okay, I can just say it, and then you can say, okay, I can just say, and you have to remove the semicolon. If you put a semicolon, it returns nothing.
Yeah.
So essentially, yeah, so we have get display message, and it takes whatever information is in this struct,
Mm-hmm.
and it turns it into a string, which is
Gotcha.
what we get in here. So far, so good. Then
Yeah.
what we do is we do all this other stuff to print it to the terminal. So how are we supposed to test this? And the answer is we're not, because this function, it's a trick question, because this function comes out of the standard library.
Yeah.
And at some level, we have to trust the standard library that it works. Like you don't have to write a test for Vic. You
Yeah.
can assume that Vic works. You don't have to write a test for standard out. You can assume it works. There are situations though where because what we're doing with standard out is a little bit different
Mm-hmm.
in Rebel terminal async, we're going to have to test our standard out, which is not the
Okay.
same as this standard out, because
Yeah.
this standard out came out of the standard library, which is part of Rust.
Yeah.
So this was a not entirely a pointless exercise. It was more of like an exercise to demonstrate that the answer to writing a test isn't to test everything. It's to be very clear about scoping down to very specifics what functionality that you have created that
Mm-hmm.
you need to test,
Yeah.
not
And that's
functionality.
what you're saying. Like that's what you were mentioning. Like, hey, make sure you review the code, look through the README, because that's extremely important when you're testing, right? So if you go into a code base, you don't understand how it works. Well, how are
Exactly.
you going to create a
How,
test for it?
you
You
really
know?
exactly. So at the very sort of like sort of outsider level, you could run the
Hmm.
program and see like, well, if I pass it this argument, it
Hmm.
should produce that output. Or if I pass it this argument, it should fail or something like that. And for that, we
Yeah.
have these BATS tests. So that's like basically like not knowing anything, we can write a
Hmm.
BATS test, sort of. But to write a unit test, yeah, you have to like know specifically
Yeah.
the exact thing that you're looking to test. And in fact, specifically the exact thing you're looking not to test. And that's where a
Yeah.
lot of issues can come kind of present themselves. So one thing we can also do is that what if we did want to test standard out?
Okay.
How would we do this? Well, where did they go? Can't find anything today. Where are they?
We'll go to that repo and
Yeah, there it is.
go.
This one, dependency injection. There we go. So this is where dependency injection comes in. So It's not a trick per se, but dependency injection is a really effective way to test things that are really hard to test.
Okay.
So under the hood, what this standard out function provides is it's actually, let's see what it is. It's just a struct, and it implements a trait. Oh, we never implemented traits, did we? Okay, let me implement a trait real quick so you know what this is. So, oh, by the way, you know this, we made this get display message.
Okay.
So in Rust, there is a trait called, we can say impl display for point. And display is, I will show you what it does in just a moment.
Okay.
Display basically takes, you remember this expression we had in get display message right here?
Okay.
Display basically does that. Only it does it a little bit differently. So what it does is
Okay.
that instead of using the format macro,
Hmm.
it uses the write macro. The but the expression is identical. If you look at the what it's formatting, this part is this exact same. So like it just goes. I don't know if you
Okay.
noticed, it's the same.
So one reads, the other one writes. So the one on the top has a read and write functionality to it, or
Yeah, well, so what happens with the display macro is that this is a convention in Rust where you can this F thing,
okay.
um, it allows you to um, like actually if you look at the format macro under the hood it probably does. Let's see, what does it do? Let's
Is it
see
kind of like the F
format.
string in like Python, where it allows you to pass in a variable or something like that?
Not exactly. I think, let me see. Format args. What does it do? Format. It just returns a string. I see. So what format does is that it's very similar to write, except that
Mhm.
write will write into something called a formatter,
Okay.
and format will write into something which is a string.
Gotcha.
So if you want to write into something that's not a string, then you
Hmm.
use this
Oh,
write
okay.
macro.
Yeah.
If you want to write to a string, then you just use format. This is a convenience basically. Otherwise, it would be really cumbersome to use
Yeah.
write, because write it expects so you can implement write. By the way, write is just a trait.
Okay.
So you can implement the write trait for any struct, and
Mhm.
there probably is a write implementation for. Let's see, is there a write implementation for string? Let's see, probably. Let me see what the formatter trait is. These are all just traits. No, that's a struct. Never mind. I mean, let me see.
So it's like typecasting allows you to change from one data type to another.
Which one?
The write function, like pretty much under the hood, does it let you like kind of typecast? So instead of it just being like the format, which allows you to pass in only strings, the write typecast, it could be a string, it could be an integer, I'm assuming.
Actually,
I might be completely off the base here. You
yeah,
could tell me.
it's the other way around. So print
Mhm.
line will take that expression and it will turn it into a string.
Okay.
Write is like, you don't want a string. You want me to take that expression and you want me to write the output of that into a vec,
Okay.
into a string, into a stream, into literally anything. It's a very
Yeah.
extensible trait, and you can
Mhm.
literally implement write for anything. So I'm checking to see. Let's see. I'm pretty sure this is. Oh, what the what? Write trait impl for string. Um, let's see. This is completely going off base.
Yeah, we could get back to it. Honestly, like, I mean, we don't have to spend too much time on this.
So
Uh,
So I think this is you can use write
Mhm.
to to write to a string.
Okay.
So basically, write is a you can do anything. You can write to anything with by implementing the write trait,
Mhm.
which is why it's a little bit more complicated to use because they have this thing called a formatter, and you're like you got to get a formatter, but
You
it's a
probably have to pass in like some arguments, right? Like it has
exactly.
arguments that you have to pass in.
Exactly. So essentially, like this one is a terrible trait to
Mhm.
pick to demonstrate for this example.
Yeah.
Uh, Absolutely horrible. But you can write a string uh, into uh, into the uh, let's see. So you can let's see formatter struct. Yeah. So basically, so this formatter. Okay. So I'll explain. Okay. Enough
Mhm.
dancing around. So what formatter does is that it's really optimized for you to be able to easily take the fields that are in a struct and make a really nice looking output so that when you see it in the terminal or log messages or something, it looks nice. That's why it's
Got
called a
you.
formatter. So when we say get display message, it's like do whatever you want with implementing the display trait because they give you a formatter. It gives you
Mhm.
all kinds of niceties which we're not using, which allow
Yeah.
you to pretty print X, pretty print Y, and it's very easy to use. Like you can do stuff like this: format debug struct. You give it the fields and the
Yeah.
values, and then it'll just do stuff for you. So sorry about that. We can deep dive into this later, but
Mhm.
essentially, the you can you can with the right trait you can basically do whatever. It's very extensible, but it's really like made for um, like structs that you want a debug output generated for. So so this is so kind of coming back to where we were. What I was getting at is that with this dependency injection, we would have to change print to standard out to something very
Yeah.
similar to this format, where we would make another version of this called this is just nonsense at this point. It would be print two, and then the two is the writer, something that implements write. So
Okay. And that's how we test the the standard out for the stand-in.
exactly. So what we would do then is we would create a writer, which is basically going to write to a string. Then we create an empty string basically. We call this function. We say go write this point into this string that we've given you. Then we would check to see what the contents of those string is very similar to this. That's the without going into too many of the weeds. That's roughly like how we would achieve that. And we can do a deep dive on that in a separate session because when we go to do the Rebel terminal async
Mhm.
tests and stuff like that, more than likely this will come up. But this
Okay.
is way too much information for one session introducing unit testing and end-to-end testing and integration testing and like dumping everything in one. But roughly, this is how it kind of goes. So if you have more sophisticated use cases, you end up using dependency injection, and you basically take standard out as an input.
Okay.
You don't assume that because with print line when you say print to standard out, it's going to
Mhm.
print to standard out, and you have
Yeah.
no control over standard out. So with this
Mhm.
function, you have complete control over this thing. And you can pass a standard out to this function because standard out implements writer, the write
Yeah.
trait. So it's a bit it's like, oh wait, so the thing that you were gonna use standard out to perform an operation,
Mhm.
that's that's an implicit dependency. That's assumed. Let's make it
Mhm.
explicit. and I'm
Yeah.
going to literally hand you standard out, and you use that standard out that I gave you to write that string.
Yeah.
But in a test, I will probably not give you a real standard out. I'll give you a fake standard out.
Mm.
And when you write to that fake standard out, I'll be able to check to see what was inside of that standard out after you're done with it.
Yeah.
And I will we'll do tests that look like that. It's much more complicated, but that's roughly where that's why I kept harping on dependency injection. Hopefully it made any sense, probably not, but if you rewatch the
Mhm.
video, it'll probably start to make more sense. And in future videos, we'll definitely get
Yeah.
into building the stuff from like instead of just talking about it, we'll actually
Mhm.
make a test and get it to work. So with that said, any other sort of questions before we wrap up? Because we covered a lot of ground today.
Yeah, yeah, no, we definitely did. I mean, it's for sure a lot of information. I think for you, it probably just comes a lot more naturally. So having like kind of like essentially dumb it down for me, can be complicated. So, uh, what I really appreciate is the fact that you did take these concepts that you normally don't think of. Like for me, running something like a, let's just say in Python, I run that print function, right?
Yeah,
Well, I wouldn't think to look behind the scenes at the actual
exactly,
source code to see how it works. But
exactly,
when you actually have that context, it, it gives you a better picture, right? So now when I'm working with these things, uh, I'm better for it.
exactly.
I know exactly what to look for.
I love it. I love it. That's fantastic. Yeah, because a lot of times we're like with Rust, that's why it's a systems language because we are very quickly in many situations down to close to the operating system, hence the
Yeah.
system in systems
Mhm.
language. So yeah, that's fantastic. So on that note,
Mhm.
let us conclude this recording. This is fantastic. We'll do more.
Okay.
So yeah, so basically, thank you so much, Juan. Stay on the line, but I'm going to stop the recording now. And so yeah.
Sounds
Oh, by the
good.
way, for folks who are watching this, if you like this style of video, give us a thumbs up and definitely subscribe. And then go to Developer Life, and we have a newsletter. I'll put all that in the description because a lot of these links came from there. Thank you for watching. Let's see, how do I stop the recording? Oh, there. This